Before we begin, please raise your hand if you have heard about hallucinations even before today. Okay, let's see, people in, you guys in Dortmund too, raise your hands if you heard about hallucination. Thank you. Okay, perfect. And now please raise your hand again if you actually experienced it yourself, that an LLM hallucinated to you.
Oh, I think
Perfect. Thank you so much. So you do agree probably that this is an issue that actually is very important to make LLMs usable, that ideally we would want some type of intelligence that doesn't do that. So let's see. Right. So what I see very frequently, and sometimes it's done in the industry, sometimes it's done even in academia. So we will take an LLM and we will use it for a brand new task that no one has done before, that there's no training data for and no test data for. And then we're going to evaluate it somehow. And then we're going to evaluate it somehow. And so normally it is a great thing that LLMs allow us to do things that have never been done before. However, at the same time, in many cases, we don't really have good metrics whether what the LLMs give us is actually useful, whether it's safe, and whether it is actually what we wanted the LLM to do in the first place. So that's where the issue of evaluation comes in. So in this talk, I will first talk about why we should care as hallucinations, both as researchers and computer scientists and as humans who are users of LLMs. Then we'll talk about some definitions of hallucinations and what they should fulfill to actually be useful. We will talk about automatic methods to detect hallucination and evaluation methods in general. And then we'll talk about the issue of human evaluation, and we will see that it's actually more difficult than it seems. We will talk about hallucinations in languages other than English, and then we'll talk about some other future directions. So most of the talk here is based on the research that I have done. If you have any questions, feel free to ask at any point. I know that sometimes I might use terms that I'm very familiar with, but you might not be familiar with them. So please feel free to raise your hand, or if you're in Dortmund, then get my attention somehow because I don't see you on the laptop. And feel free to have a question anytime you want. So first, let's talk about why we should care about hallucinations. So this chart shows the evolution of hallucinations or the interest that researchers have had in them. So we took papers from major NLP conferences and we took a look how many of them talk about hallucinations or other words that are commonly used for them, such as confabulations, semantic inaccuracies, and so on. And we took a look at how many of those papers mention hallucinations in the body of the paper, in the abstract, and in the title. And you can see that there's an exponentially growing trend where nowadays a quarter of NLP papers talks about hallucination, whereas it was only 5% before. So we see that this is something that not only happens more frequently, but actually is talked about more frequently, which is good news because it means that we're aware of this issue and we're trying to do something about it. And then we take a look at how frequently papers actually use human evaluation to detect whether LLMs are hallucinating. And so this figure shows papers which mention the word hallucination, confabulation, or a synonym, and also whether they perform human evaluation or not. And we can see that 2019 was the year when GPT-2 came out, so it was a large language model that was already very good for that time. we could do a lot of great stuff with it. It wasn't so well adaptable to new tasks. You have to have fine-tuning data for that. But even then, people started talking about the issue of hallucination. And so you can see that around the time in 2019 and 2020, almost 70% of papers that talked about hallucination in some way used human evaluation. However, nowadays it's less than a half. So how do we even know whether the models are hallucinating or not if we actually don't use humans to evaluate that? And the good news is that more and more human evaluations are actually being performed. So at least that's a good thing, but we can still do better as a field. And also the yellow line or orange, depends on which screen, shows you how many papers actually show the information about human evaluation in the abstract. Because normally in the abstract of a paper, you write what you think is very important and that the reader should know before reading the full paper. And we can see that papers report this less and less. So they find them less useful. So what are hallucinations anyway? And I'm not a proponent of having like a single definition of hallucination. We can agree that it is some unwanted information that's present in the output of large language models. However, the exact definition really depends on the task. Are you trying to do open-ended question answering? Then your definition is going to be very different than if you're trying to do medical summarization. And so what we can agree on is that if we want to define hallucination in a meaningful way, we should first talk about what's our grounding criterion. So in the research community, this is oftenly called whether we're talking about faithfulness or factuality, where faithfulness is for faithfulness, we ask whether the model is being faithful or true to the input data. So you would encounter this in tasks where you have some data on the input that you're just trying to transform. So you might have a table of data and you try to understand what's in the table. So you might show it to a large language model to give you a summary of the information in the table. Or you could have an article and you just want to see if it's interesting and if it's something that you should read. So you want to summarize it. So in these cases, you would care more about faithfulness. However, in some cases, such as open-ended question generation, you care whether the answer is actually true in the real world. So whenever you have any projects working on hallucination, I would urge you to think about what's the nature of your task, what are the needs of your task, and which grounding criterion you need to use. Then the next thing that every clear definition of hallucination should have is the verifiability standard. So sometimes people consider something a hallucination if it contradicts the grounding criterion, and sometimes they consider it a hallucination if it's just new information that hasn't appeared there. I mean, you might consider both of them an error, but it's up to your discretion whether they are both equally important to you. And then another dimension that the definition should have is error granularity. So think about whether you want to have just like a 0 versus 1 distinction, there's no hallucination versus there is a hallucination, or whether you actually want to have multiple stages of severity of hallucination. So you might have some minor errors in case the model just adds something that doesn't really change the meaning. And you could have major errors where the meaning of the output is changed dramatically. So let me show you some definitions that actually have been used in research papers. I'll give you some time to read. So, have you had some time to read? Now, please raise your hand if you like the definition on the top better. Or do you prefer the one on the bottom? Okay, so top, please raise your hands. Bottom, you prefer the one on the bottom?
Yes.
Okay, interesting.
So the top one is not general, right? It's just.
It's for a very specific use case, yeah. Yeah, the bottom one actually I'm very perplexed about because I have no idea how to even grasp the definition. Like it feels very circular and it doesn't feel like it offers a lot of information. But it's cool that human preferences are different. And this is actually something that we will later encounter when talking about human evaluation, right? Like humans can have different preferences, can consider different things important, and therefore often disagree on tagging hallucination. So now moving on to the next part, which is automatic evaluation. So I will generally describe multiple different types of evaluation using Futurama characters because I just find it very fitting. So the pros of automatic metrics is that generally they're consistent. So if you use a metric with a stable implementation, you're going to get the same results every time, which is very important in science because you want to be able to compare your results to some previous work, and you want to essentially, if you have the same data, you want to give the same metric judgment. Also, another great thing is they're quick. You don't need to wait for anyone to use them. You can just run them, and generally you have your results very, very quickly. Generally, they're also very cheap. Now we have metrics which may require a GPU to be run, but still, if it's something that you can run locally, it's much cheaper than running any sort of human evaluation. And also they scale very well. So even in a setting where you might have millions of texts that you need to evaluate, you can use this. However, at the same time, it is generally just a proxy for a more accurate form of judgment. Also, having a metric score doesn't necessarily tell you about what exactly the problem is in a given text, so that makes it less informative. Sometimes you just don't really have a metric that would work for your task, your domain, or your language. And you sometimes don't really see what's going on and sort of why they make the judgments as they make them. And now the asterisk here is because of LLM as a judge. So with LLM as a judge, it alleviates some of the cons. However, it also takes away some of the pros. So especially if you use something like GPT-4 as a judge to be able to measure the quality of your system, if you run exactly the same code and exactly the same data in 2 weeks, you might get a different result. So this makes it a little bit trickier to use. And also, in such a case, you can no longer say that it's very cheap. And so why I chose Bender for this slide. So Bender is actually a very good representation of many automatic metrics, because essentially his main task is to bend different steel rods into multiple angles. So he was literally born to bend a steel, like pieces of steel. And however, you can kind of bend him to do other tasks as well, which is something that we usually do with the automatic metrics as well. So he can actually become a member of the crew of a spaceship. However, it is not what he was designed to do in the first place. So, how can we actually do human evaluation? So, in the first scenario, which is the easiest one, you have a task which has exact questions. So you might be asking, what's the capital of France? Well, there is one answer. Or you might be asking a mathematical question that you can then check. In such a case, you can simply count how many times the LLM got it right, how many times it got it wrong, and you can essentially grade it almost as if it was taking a test. The most frequently used way to evaluate most NLP systems is reference-based metrics. And so how they work is that you have a reference that was written by a human, which you can imagine as the picture on the top. And then you compare it to something that was produced by your system. And you can imagine that as the thing on the bottom. And now the reference-based metric doesn't necessarily tell you what exactly is wrong about your output and how to get it right. It only tells you that you are pretty far from what it should look like. And then we have open-ended evaluation methods. And here I chose this picture because doing open-ended evaluation kind of seems like you're stumbling alone in the dark, and it's still very much an open problem where we need some more visibility. So let's talk about what's kind of good or bad with automatic match. Oh, yes.
About the reference-based evaluation, don't we also introduce a substantial amount of bias into our evaluation by supposing that the reference must be the correct answer?
That is a very good question. Yes, I absolutely agree with you. And to be honest, I'm not really a fan of reference-based evaluations. There are people who will say that we cannot absolutely conceptually evaluate anything unless we have a reference, because how else are you going to know if it's right? And there are multiple metrics that allow you to have multiple different references. So sometimes you're not saying that there is a single right reference solution. There are some cases in which you might have more reference solutions available. And actually, there are many papers arguing that based on what your reference looks like, you might have completely different outcomes of the evaluation. So you're right. I agree with you, and that's why I don't work on reference-based metrics. And at the same time, people really use them because there's a lot of data that has the references available, and it is literally the simplest thing that you can do. So yeah, it's available and it's abundant. And actually, this point that I'm currently displaying on the slide is there specifically for one reference-based metric. Because so what we can do is when we have a lot of systems, we can have humans evaluate them, we can have some automatic metrics evaluate them, and then we can take a look at how these measurements correlate between each other. And actually, many reference-based metrics have a well-documented poor correlation with human judgment. So we already know that they are very poor proxies for whether humans might like the output or not. But we generally use them because they're quick and cheap and better than nothing. Then many metrics actually cannot tell you whether there are any factuality or faithfulness issues in text. So a lot of the reference-based metrics you can simply go around by adding the word not, because then the distance between the reference and the solution that you're trying to measure is actually not that much further away. However, the meaning has changed completely. Also, there are some popular metrics that have multiple implementations. Some of them are non-deterministic, so this is definitely good to keep in mind. We already have a lot of libraries addressing these issues, but not everyone is using them. So this is still something that that is important to talk about. And also, something that's frequently done in some papers is that they will compute something like 15 different metrics, and they just put all of the numbers on the paper, and they're just like, well, dear reader, just pick your favorite metric and make some judgment based on that. And that's a practice that I don't really like. And so when we take a look at which metrics are actually used in research, and this is based on a survey that we did last year, we can see that the vast majority of metrics is reference-based. So the ones that have a poor correlation with human judgment, the ones that can be biased, and sometimes cannot really tell us a lot about whether the model hallucinates or not. And these are some of the specific metrics. If you take any introduction to NLP classes or machine translation classes, you will be more familiar with them. But just to sum up, the ones in red are based on how many n-grams or words overlap between the reference and the solution or the produced output, versus some of the green ones are based on semantic similarity. So you represent the reference and the hypothesis as a vector, and then you try to find the difference between them. And there are other metrics that are being used, but these are the most popular ones. So my recommendations, if you need to work on any projects where hallucinations are an issue and you want to evaluate them, so my number one pick for this is a natural language inference classifier. So that's a model that has been pre-trained. You can download it from Hugging Face, and it was trained to predict the distribution of logical entailment or contradiction or neutrality between a hypothesis and a premise. And it's something that in my experiments worked the best in multiple domains and scenarios. But one very important caveat to point out is that the newer the model is, the better, because I actually had very mixed results with older classifiers. And by older, I mean 2023 and 2022. So make sure that your classifier is as new as possible, because LLM errors evolve and the classifiers need to evolve with them. And a pro of this method is that you have these classifiers available in other languages as well. Many of them are natively multilingual. However, I personally don't have experience with how well they work for other languages, but it's something that I would want to try. So in case any one of you was interested in seeing how this applies to other languages, please talk to me and we can definitely work on it together. And one thing that's very, very old-fashioned, but very hard to beat, and it's super simple. So you literally take a look at how many words which are in the output text, taking a task such as summarization or data text generation. So how many of the output words are also present in the input? It's very simple, very easy to cheat, but also if you need to evaluate millions or thousands of texts and do it for cheap, this is a very good proxy actually. I mean, you need to take it with a grain of salt because it's very simple, but sometimes simple methods work really well. And then another thing to try would be semantic similarity based metrics. And these, as I said before, will represent, you can use them in a reference free scenario. by representing your input as a vector and your output as a vector and trying to measure the difference between them. Okay, now we will go to one of my favorite types of annotation, and that's span annotation. So what I really like about this family of approaches is that not only you're interested in is there an error or not, but you actually want to point out where exactly the error is. And so what this might look like is this is an input text. So a description of a hotel, which is 5 minutes away from the Mall of the Emirates, and mentions the Dubai Marina and Dubai Mall. And so you can summarize it saying that you can enjoy access to the Mall of the Emirates, which is fine. And this should be an X. And because it's incorrect to say that you can enjoy breathtaking views across the Hudson River to New Jersey and Liberty Island. So while it is true that you might have breathtaking views, if the breathtaking views are from a hotel in Dubai, you are surely not going to see anything in New Jersey or Liberty Island. So this is something that is wrong and can be pointed out specifically. And so now you can either train a model to do this, but as of right now, we don't really have a lot of data to do this. So as I mentioned previously, LLMs are good at many new tasks. So why not try LLMs for such a task? And turns out that when you have tasks which have been established for a long time, you have a lot of human judgments on those tasks available online. Like there's been a lot of data to text research going on since, well, probably even sooner than the 80s. Definitely, we have been doing machine translation for a lot longer than that. And these are generally tasks where we have many competitions. And with the competitions, we generally have data and some human judgments on how to evaluate the data. Also, we tested this method on propaganda detection, and turns out that it works kind of similarly to humans. It's a difficult task, but also LLMs have learned a lot from different fact-checking data sets and so on. However, when I tried this method on a different data set, on a data set such as the one that I showed you previously with Dubai and the Mall of the Emirates and the view of New Jersey, turns out they are pretty bad at that. So what do I mean? So in the shades of blue, you have human judgments, and this is the data set level distribution of errors. So you can see how many errors were found by two different groups of humans. I already talked a little bit that humans don't necessarily agree with each other, which is fine because we all have different preferences. However, when we take a look at what the LLMs do, we can see that while Gemma actually does have some agreement with humans on what the errors are, it might confuse some types of errors, but generally it's not doing anything too wild. However, GPT-4o is finding errors absolutely everywhere. So this column stands for the examples where the given method displayed as a bar did not find any errors. And essentially what GPT-4o does is that it goes through the data and it just says, this is an error, this is an error, this is an error. And I looked into the data because we have also collected reasons for that. And some of the reasons would look like the description says that there is paid Wi-Fi at the hotel, and the summary says there is paid Wi-Fi at the hotel. This is wrong. Okay, so we can see that the LLMs might be too overeager to find errors. On the other hand, LLMs might also be too prudent about finding errors. So when you take a look at the red lines, and you can even see 1 here and 3 here. So O3 Mini found 4 errors in total. In those 4 errors, I completely agree that they are very valid errors. The reasons look great, but it's pretty expensive, and you're not going to use it if it misses a lot of errors. So you really need to be very careful. And by the way, I did try to prompt the model to be less strict, especially for GPT-4o. Do you want to know what happened? It found even more errors. So, to be honest, it's a closed source model. I can only call it via the API. I cannot dissect it and study it. So I cannot really tell you why exactly it behaves this way. However, I did notice that the model is not suitable for everything. And if you want to use LLM as a judge, please validate it first, because otherwise you might have a completely different picture about what's going on in your data than what's actually going on there. And if you want to try out Sun annotation, my colleagues and I have built a tool for that, which allows you to use both humans and LLMs to make these kinds of judgments. So now to the next part. How hard can it be to ask a human whether there's a hallucination in the data? Well, the first question is, what kind of a human? So meet Professor Farnsworth, who's the expert in our case. So he completely understands what the topic is, and can give high quality feedback. That feedback can be used to improve the systems, so it's very valuable. And also, you don't really need to explain to the expert what you're looking for, because they know what's the use case of the tool and what you want to use it for. However, they are very, very expensive, and their effort is very valuable. So you don't want to use them to annotate thousands of different data points. So this means that whenever you use experts, you are likely going to have a low quantity of data. Also, experts might be potentially biased, sometimes because they don't want AI to take over their job. Sometimes they have their human biases, and that's completely fine. We all have them. So it's something that you should be mindful of. And this is not something that would scale well. On the other hand, you have non-experts. So they can be crowd workers, so people you pay over the internet per task to do something for you. Or you can also have some in-house annotators to do that. So right now, they're the gold standard of evaluation, so what most papers and research use. And they're relatively flexible. You can just open a task in the middle of the night, and there's going to be someone in the world who will take that task, whatever the task is. They can annotate a lot of data. So this is something that you can use to annotate your training or test data. And they're significantly cheaper than the experts. However, they're also slow, and you need to explain to them relatively well what you want them to do, because they are not familiar with your task. Sometimes, if you're not careful, the data you get from them can be of questionable quality. So you really need to do attention checks. You need to pilot your experiment to see if your guidelines are clear. And also, unless you want to be an unethical monster who pays them less than the living wage, you really need to pay them, so that's still expensive. And so who are the people who research generally uses to evaluate what hallucinations are? Surprise, surprise, most of them are students. So in this case, it's questionable whether they are even being paid for this. But most papers will gladly tell you our model hallucinates less than the other model because our students said so. They will not say this in a way like I did, but if you read the paper, that's essentially what they're saying. Then the crowd workers are the next most common group of annotators, experts. Some papers will not even tell you who the annotators were. So sometimes it's the authors themselves doing the annotation. They might have some professional annotators and volunteers and whatnot. So my recommendations to you, if you want to do a human evaluation, is whenever you design your human evaluation experiment, there will likely be some errors, something unclear. So pilot it. You can either do the experiment, do the annotation yourself for a couple of cases to understand whether maybe there are some borderline cases where you have an opinion of how they should be resolved, but it might not be clear to the other annotators. Or sometimes you can ask your colleagues for help just to annotate a couple of examples and give you feedback whether everything was clear and whether the annotation interface you're using is user-friendly. Maybe you need to explain some more. Also, examples are also very, very important, and it's the best way how to communicate your intent across. If possible, then you can use definitions of criteria that you evaluate from previous work. And as I said previously, specify your grounding criteria on verifiability standard and error granularity. Human evaluation datasheet is something that as students you probably don't really need to use. However, it's something that I would recommend to researchers. It's this huge datasheet where you can log all of the design decisions about your human evaluation study, and also report the agreement and release the annotated data. And now, for the last part of the talk, I will share a case study that I worked on recently, and that's cross-lingual summarization. So on the input, you get multiple reviews of either a Google Maps restaurant review or an Amazon product review, and they're written in their original languages. So this might be almost any language you can think of. And we restricted this to 21 languages on the input to have it somehow manageable. And then you ask an LLM to give you a summary of all of those opinions and reviews in a given language. And we used 14 languages for the outputs. And so this was intended as a competition. So we have a lot of different models that have performed this task, and we evaluated this using first automatic filtering. So a lot of the times we asked the model to give us output in a particular language. It would use a completely different language. So there were some models that were only using English on the output. There were some models which they said they were producing Czech, but were actually producing Polish. And now I thought, well, this was weird. Like, this has to be some error of the classifier. I speak Czech. And so I looked into the data. I was like, yeah, like I cannot say whether this is grammatically correct Polish, but it definitely looks like Polish. So sometimes the models don't even get like simple instructions like this, right? So we use the filtering to get rid of those cases. Of course, we ran a human evaluation, and we also tested out LLM as a judge to see how good it is. So the biggest takeaway from this huge table, and you don't have to focus on the numbers, you can just focus on the colors. So LLMs hallucinate at different rates in different languages. So we don't have English in this table because we wanted to focus most of our efforts on languages that are less explored. However, if you're using Gemini in Japanese, then you are probably losing out and getting more hallucinations than if you asked it in a different language. Also, LLM as a judge is shaky for all languages, but also the performance really varies based on the language it judges. So it's not the universal solution to all of the open problems in evaluation. So what's next? So these are some of the topics that I would like to explore. And so the first one is better automatic methods for reference-free hallucination detection. Then I also want to work a little bit more about what kind of protocols we can design to have more stable results from human evaluations. And then last but not the least, we should start bridging the gap between English and other languages to make them more useful for the entire world. And one way we can do that is by having better evaluation for those languages and also understanding better what goes on in the language models as they produce those languages. And then very importantly, we can improve the things we can measure. So that's why evaluation is important and something that I work on. So thank you for listening to my talk. If you have any questions, I'm here, or you can reach out.